Hi everyone, this is Sebastian. I'm principal engineer at Kiln, working mostly on Ethereum, and I'm very pleased to have Terence here, who is a core developer on Ethereum, working on the Prism consensus client, which is one of the main consensus client on Ethereum. And we also have Loic, who is a senior product manager at Kiln, also focusing on ETH. And today we are going to talk a bit about the next Ethereum upgrade, which is called Pectra. And we'll also have some cool insight about what it looks like to develop on the consensus side from Terence. So yeah, welcome Terence, and I'm very, very happy to have you here. Could you introduce a bit yourself, maybe a bit more than what I did?
Yeah, sure. Thank you for having me. It's a pleasure to be here. Big fan of Kiln, and what you guys are doing is really cool. But yeah, so I'm Terence. I've been working in this space, Ethereum, since 2018. So I work on Prism. It's a consensus layer client. It's written in Go. So nowadays my focus is more on scaling. So execution scaling, for example, EPBS. I'm sure we can talk more about that. And I also spend a lot of time on Fossil, inclusion list design. So yeah, just happy to be here and happy to chat about anything.
Nice. So you've been a long time working on the Beacon chain. I guess you were there from the very beginning. How did you start working on it? What brought you to Ethereum?
Yeah, so it's actually a funny story. So back in 2018, I wanted to do something with Ethereum, but there wasn't so much to do because of the limitation of the blockchain was, I guess, fairly limited at that time. So I came across this post by Vitalik sharding. And then, so I was, oh, this is really cool. And they are offering a grant, so I could work on that. But then it turns out we forked Geth. So we implemented sharding through some sort of smart contract logic. And then there was a parallel effort going on. They're doing the same thing, but for proof of stake. So back then, proof of stake was you use a small contract and then you stake 1500 ETH, and then you do some sort of checkpoints, which today they're what we call FFG checkpoint, but they're using the smart contract to do that basically. And so I guess at the end of the day, there was essentially this two parallel track, one sharding, one proof of stake. And then back then, people wanted to prioritize proof of stake, which I think was the right decision. And then at the same time, Justin came up with this idea of using BLS signature aggregation, which enable us to actually implement a new protocol. And that's what we know a beacon chain. So then we're like, okay, well, what should we end up doing, right? And then we thought, okay, well, beacon chain is a great idea. So we started moving from working on sharding to implement a beacon chain. And then we started this Prism consensus layer client. And basically that's kind of the story, how I started it. And then basically the rest is history.
Nice. That's a very cool way to start working on ETH, I think. Probably had a huge impact on the chain and a lot of decisions that were made afterwards. So yeah, congrats. So yeah, let's start talking a bit about Pectra. So this discussion is going to be mostly on the consensus side. So but the Pectra upgrade has two sides. There is the execution side and also the consensus side. So on the consensus side, I guess the main EIPs are the max effective balance, which means validators will be able to have more than 32 ETH of effective balance. And the goal of this, and we'll discuss a bit more about it, is to reduce the number of validators on the network. And there are also some implications on slashing behind this. There is also an EIP 7002, which is about being able to exit validators from withdrawal credentials from the execution layer, which was not possible before. So it had some custodianship issues, especially on the staking landscape. And there are also EIPs about blob throughput increase, and also some simplification on the deposit process, which means the delay between the moment you send your deposit transaction and the moment the validator is active on the Beacon chain is going to be smaller. So that's, I guess, quite a lot of changes on the consensus side. As you have seen, all of the prior big updates of Ethereum, like and on the consensus side, like how does this upgrade looks like from your perspective?
Yeah, I think it's interesting because it kind of from the outsider's point of view, you guys are looking at it. It has a little bit of everything, but it doesn't really have like that one thing, right? Because if you look at every hard fork so far, we're starting from the merge, then we went to Capella, which enables withdraw, then DNAP, which enables blob. But if you look at this hard fork, you're like, what are we doing here? It seems like it has a bit of element with everything. And I kind of think that's a feature, but also like a bug because of we don't have this common theme that we put everything together. It's slightly more messy as we learned, which we can definitely do better, right? So I think like for definitely, I think the theme of this hard fork is just that it doesn't have a thing. It has a little bit too many things. Because of that, there is this diverse interest, right? People want to, like, I work on this EIP, I want to get in. You work on this EIP, you want this to get in, right? And then on top of that, there were EIP complications. For example, if you look at the EIP, it may seem just like one line change. For example, we update the attestation structure by moving the committee index to a different location such that we can do less hashing, but it is like 1 to 2 lines change in the spec, but it turns out it's really hard to do in a client code, and that didn't show up until later when people started coding it, right? So this is something that we also learn as well. And then the third thing I wanted to point out is that I think we do realize that at the end of the day, testing is a bottleneck, which I want to shout out ePanda ops like Perry, Barnaby, and those people are doing such a wonderful job, but it is limited at the end of the day, right? When you have so many EIPs in a hard fork, we need some sort of fast testing or testing for a long time. And then the more EIPs you have, and the more service you have to test, and there's no way around it, and that also prolong the time as well. So I'm actually really happy that Pectra is coming along. I mean, we have a date. We know when mainnet will be, but now going back, I might do a few things slightly differently. But again, this is a good learning lesson for everyone. This is like, I think the first time this has happened, and basically we are learning from it.
I think this is like very interesting what you pointed out, like the testing parts, the different EIPs that you realize are a bit more complex when you go from the draft to the implementation. Maybe like as you're really like into these processes, maybe you can clarify, expand a bit more on this. If we double click on this, like, can you describe, like, for example, for Pectra, like what was like kind of the initial discussion phases for this hard fork? How like EIPs were decided to be included inside the upgrade, and kind of
Right.
what Prism did into that. Did you push certain EIPs? Did you push the testing for these EIPs? Like how does it work in terms of coordination there?
Yeah, definitely. That's a great question. So I think like I can maybe chat about like a general process of EIP, then we can look at how Pectra did it, which is not that much difference, right? Because if you look at in general from the history, like I mean, there hasn't been that many EIPs that got in. Most of the EIPs that got in are pretty like non-controversial. But these days we're seeing a little bit more controversial EIP that where like client A wants it, but client B is against it, right? But typically how it works is that you have an idea, you write down your idea, and then you talk to your friends, and then your friends also like this idea. And then you start writing these EIPs, right? So EIP is this like, I mean, I'm pretty sure the audience here know what the EIP is, but you have the EIP and then you find your co-authors, and then for the EIP, and then nowadays I think you have to do a little bit more. You have to like think about the test cases and stuff like that, and then you try to get community feedback, and then people thumbs up, thumbs down. If you have enough, like I would say like political influence at this point, then you can go to ACD and like propose it basically. And then like people like it more, blah, 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 blah. Then you get clients to implement it. You have to convince like 5 clients or even 11 clients if it's both CL and EL, right? And then you kind of have to go through this weird phase. It's what we call like vibe check. Like, does he have good vibe? And then this is very, very subjective in a way that like, I don't know how to describe it, but it's like, it kind of becomes a popular contest in a way. And then if there is like, I would say more clients like it, or even more popular clients like it, you probably have you probably have an easier time pushing it. If Vitalik likes it, then you're definitely good to go because he has a lot more weight than what he says, right? But then again, right? So people implement it. You kind of survive this vibe check phase, and then you do some dev nets, you do some test nets, and everything goes well. You go to mainnet, right? That's kind of like a process, and it's very like rough. This is what we call rough governance, and then I guess it's also by design doing it this way because like it doesn't have any like coin voting, for example, which is really hard to bribe people. Which is I think I think it's a nice process. Now going back to how Petra worked, in the beginning was that which we did this part really, really well, that all the client devs, all the client teams, they review all the EIPs that's out in the open, and then they basically come up with this that says that we want to implement this. So Prism had this, Lighthouse has this, Red has this, and given that this, we kind of just pick some like greedy simple algorithm. We take the union or the interception of those, and we propose those for Petra, and basically that was it, right? And then I think there were two issues there. The first issue is that when clients look at the list of EIPs, they probably don't know what the community wants. I mean, they do. It's not like they don't know, but they may miss a certain points, right? And then another problem is that when we choosing the list, it was a time A, but at time B, the priority may change. For example, like scaling wasn't like that big of an issue last year during like say summer-ish. Maybe it was, but it wasn't like this urgent. But nowadays, like blob scaling is very, very urgent. That's what we know we want to work on, right? So we added a bunch of EIPs that's more, I would say, staking friendly to like Lido, Rocket Pool, and stuff like that, which doesn't really address the most priority today, unfortunately. I think that's another problem. Yeah, so I think those two are the main problems. And again, like there was this Eat Magician thread out there by team that all the clients had their input on Petra like retrospective. And yeah, definitely encourage people to read that.
And as the Prism team, like what would you say is your focus here? Like, do you take an active part in this vibe check part where like would you say like most of your time is like kind of vibe taking EIPs, trying to do POCs and tries to test them and see if they make sense, or do you kind of go along with the community as well? What's your approach there?
Yeah, so Prism, I think luckily has some weight then because of I think at the end of the day, like client diversity matters a lot. But Prism and Lighthouse, I think Teku are the three most used clients. So I think like probably perhaps outside of EF research, the more client share he has, ideally, email has more influence in this process. I think for us, it's like for Petra, we are less opinionated on what it got in. We're more just we didn't really like, we were not in any of the EIPs as far as I remember as an author. So we're just like implementer. We implement the EIPs, we give feedback to the spec, we find bug, we help with testing and stuff. I think for Fusaka, we may be slightly more opinionated because like we have EPBS and stuff like that that we would very like to push to get in. But for Petra, we're more like playing like a system type of role. Yeah.
So this is quite interesting on the EPBS side. So as you are like championing this EIP and trying to push it, so yeah, there is a big part of like, as you mentioned, that is quite political where you have to convince other teams. Could you like tell us like a bit what it entails to? Like, are you like writing implementations of EPBS before proposing it to other validators to like show them how hard it is? Like how do you help other validators?
I think nowadays it's a bit harder than before, because nowadays it requires you to do a lot of work. That is, I can tell you what we did for EPBS, and it's mostly POTUS, so shout out to him, is that we had a EIP, we had a consensus spec. On top of that, we have a annotated consensus spec, basically. They basically break down consensus spec into a longer form. Each has rationale. And then some of those actually have some like for choice proof and stuff like that, basically. And then we had a lot of short write-ups on why EPBS made sense, why delayed execution helps with, for example, blob scaling, gas limit scaling, even complementary with fossil, it's complementary with pre-confirmation and stuff like that. So we have been doing a lot of like, I would say, posts, like write-ups around that, outside of like technical work, basically. And then at the end of the day, like not everyone agrees with EPBS because of the auction mechanism, how the auction is basically happens. People today, some people do like going through the relayer, because the relayer can do this some sort of second price auction, because they can like refund they can refund basically, and then relayer also takes a cut and stuff like that. Some people like the relayer because they think it's like much faster. Relayer can propagate all the blocks much faster than a proposer can. They can use this centralizing point as like a favor and stuff like that. And then EPBS does have solution to those, but it's less known to people. So we need to do, unfortunately, a bit more education on that front. So for EPBS, besides those, we also have a comprehensive spec test as well. That making sure the existing spec test pass, and we're working on comprehensive spec test alongside that. And then we do have a single client, DevNet has been up and running, but then we also added Taku to the mix, so now Prism and Taku could finalize together. But we also need to convince Lighthouse, Nimbus, and Lodestar to come with us to join the journey as well. So that's kind of like the hard part, to like convince the client teams to spend resource on working on this. And yeah.
And I guess the next steps here will likely be around builders as well, right? Because it also changes the way builders are going to push their blocks, right?
Right. So builders becomes the relayer in this sense. So builder into absorb relayer, basically. But then again, I think we're very open in how that auction part works. All we want is this separation between execution payload and the block. I think everyone agrees in the Ethereum community that pipelining is good. We need to do pipelining. But then the question is that how do we do that pipelining? There are different like solutions out there. EPBS is one of them, for example, right? I think there's definitely some people they're against EPBS because the first point is complication. They think it's slightly complicated, which I don't think that's true. If you look at the spec today, it's actually pretty simplified. The second thing is that they don't like how the auction mechanism is done in EPBS today, which in the spec today, that auction is the minimum part. The auction is like you don't even have to care about the auction. You can we can do separate auction if there's a feedback on what auction mechanism is better. But all we really want is essentially that pipelining. You can separate block with the payload, and we think that is the future that Ethereum should be heading towards.
Makes sense. Thanks for the detailed explanation. So on another topic which we briefly touched before, so like the Prism client team has been around since the beginning. So it had like to implement all of those EIPs along the years. So there is like at the moment like the EIPs are let's say crafted, like as you said, like the priorities can change, and sometimes some EIPs can be a bit like old once they get to mainnet, to the point where maybe they are not needed anymore. So there is kind of like this sensation that you are carrying a big bag of like EIPs when you are developing a consensus client. So first, like, is it like really the case? And if so, like, how do you see like the balance between like, let's say, implementing new features, but also like have to take into account like the times that you have to handle all of those corner cases that were like previously introduced. Like, basically, how do you feel the technical debt, if I could call it like this? And maybe
Yeah.
it's not like the right term here.
Yeah, I think like luckily I don't work on execution layer client. I think execution layer client feels more than us. So we only have been around for 4 years versus them has been around for longer. I think EOF is a good example that like some teams are against EOF because now you have to maintain these two separate versions of it, which kind of sucks, right? But I guess for consensus layer client, yes, I mean it is true that there are legacy code that we have to maintain. But I would mention that like there are EIPs that we're working on or tools that allows you to delete technical debt. I think one example is like EIP 6110 that essentially the deposit now comes from this engine API versus having client to essentially query the deposit contracts log event because that takes about 8 hours versus you just get it through the engine API, it takes about 30 minutes. And then because of that, we can delete the old code where we just keep looking at log events for deposit contract because that code is not very nice anyway, right? I think that's one example that, yeah, we can do. And I definitely think we should have more EIPs like that. I think we shouldn't be afraid of deleting history. I think that's probably a controversial thing to say, but I think like at some point history should just have this like all of one honest minority behavior that as long as you trust that one person has a history, you can get it from it, then it's good. I don't think every client like or every node or every running node should keep the history because that's just not gonna scale, right? Like I think EIP 4444 is another good example. I think it's coming at some time this year that like the EL will just start with a snapshot. Hopefully, I think it's post-merge. So pre-merge, they will not get the data anymore. And I think that's very nice. And then I think in the future, that I'm pretty sure maybe we'll talk about it later, is that when we reach Beam Chain, that's another paradigm shift, right? I mean, Beam Chain is a very popular topic. I don't know when we'll get there, but it sounds like people are very interested in it. But once we get to Beam Chain, that like it's kind of like Beacon Chain 2.0, right? So you can kind of redo Beacon Chain client in a way that makes more sense for ZK stuff. So this will also allow you to delete the old code.
Yeah, so maybe talking about Beam as you started introducing it, how do you see like these, like basically how do you see in general like the future of what Prism can do regarding like the future EIPs like in the next 5 years? You know, there is so much to do. It seems like each hard fork is more and more has more and more EIPs. And then there is this big Beam project, which is kind of a complete refactoring of the consensus layer. How do you approach that as Prism, like both this kind of scaling with a lot of EIPs and the refactoring coming with Beam? Do you think it's realistic, or how do you approach that as a consensus scaling team?
Yeah, I think it's hard. I mean, I can't speak on entire Prism team. I can speak on what I think. And then again, Lighthouse, Nimbus, Tehu, they all face the same dilemma, right? The dilemma here is that we have our daily job. Our daily job is to make Prism as great as possible. We have a set of EIPs, we have hard fork to load towards. And then in parallel, there is this effort, it's basically Beam Chain, basically. And then Beam Chain will essentially revamp the state transition function. You will probably need a new SSZ layer and then networking layer because of everything has to be ZK friendly. So maybe you have a new hashing function, for example. That's another parallel effort, right? So essentially, client teams, they need more resources if they want to keep up with Beam Chain, unless they want to do them on their side. What I'm hopeful for is, I'm not sure if this will happen, but I'm really hopeful for is that client today like Prism, Lighthouse, Nimbus can do what they're doing, what they're good at. But at some point, transition to Beam Chain, just some sort of like swapping out, based like a swap out. So you can think of Beam Chain as just a state transition function. So Prism can essentially code that code, essentially, and then and then we can just black box that state transition function. I think doing this will require some architecture changes, how we do code. I think every client code is different. Some client code may be harder to do this, some client code may be easier. So I think it's never too late to start planning these type of things, that thinking like what to do when Binchain comes. We still want to maintain Prism client. I don't want Prism client to go away. But the question is that how do we make Prism client workable under this Binchain paradigm? I guess it's too early to know. We haven't seen any much technical details outside of Binchain besides Justin's announcement. So once we see the spec, once we see what that Binchain is, I think we will know more.
So yeah, just a quick question on this. So right now, the state transition function is basically like there is no clear separation, I guess, in like existing consensus clients between like your let's say networking code from like the actual state transition function. Like so, I guess that's the main challenge if you want to rely on existing state transition functions that could be done by other things. Or
Exactly. And another thing I want to mention is, I think if you look at Justin's list, I think there are 12 teams right now, and like everyone's working on 2 languages like Rust and C++ and C, right? And no one's working on like Go, for example, because I think the truth is like Go is not great at coding other languages. I think that's gonna be a problem down the line. Is that how do we make Go more efficient at coding C code or coding Rust code? Because at the end of the day, those state transition functions will be written in Rust, something that can compile to Watson RISC-V for basically for ZK proving and stuff like that. So that's something that we have to figure out. I think it's a very interesting problem. Yeah.
so just on this topic of languages, so like if we like don't talk about Beam, like just on like the purely like what was done so far on Prism, do you see like in retrospective, like from everything that was done, like architectural mistakes that were made in Prism, or like maybe places where you feel like Go was not the right choice, or maybe like where it was actually the right choice? Like how, what's your take on 6 years, I guess, of Prism development?
Yeah, I think Go has a few advantages. The first is Go is good at like client-server architecture stuff. For example, like Docker, Kubernetes, they are written in Go. And Go is also easy to read, so meaning that you're easy to onboard developers. I think that's another good thing. And then Go is also good at like concurrency stuff. You can do that, and then it doesn't, and then and then you can like spin up your own Go routine, and then its memory management is also easy to deal with. I think those are the advantage. It's not as like powerful as Rust, for example, as C++. In terms of like mistake, I think there were a few, right? The first one is that before there wasn't this Beacon API when we started, so we ended up implementing our own like Prism version of Beacon API using gRPC. It turns out like we probably didn't need to do that. Now we have literally 2 API to maintain, which we want to deprecate gRPC API soon. But then again, it's very hard to do that because you can have like production system that I don't know how many people are actually using it. So we have to deprecate it more like carefully, for example. And then another one is that, we definitely rely on gRPC way too much versus we should just use native Go struct for everything. That would have been cleaner. And I think that was probably the main thing I will probably go back and fix.
Yeah, I think this is one of the topics that Manu worked on at some point. He was.
Mine was great.
Yes. Okay. So it's very interesting to have your insight on this. Like, thanks a lot. So now back to Pectra. Like, sorry, I feel like we are in a labyrinth and we are trying to get out and like we navigate from one topic to the other. So back on Pectra, like on the max effective balance EIP. So one of the goals is to reduce the validator set. And so like what it means basically, like because you have less validators, you have less network congestion, you have like less processing, and so like it's like you have basically like more rooms for potential features on the consensus side. So do you think like in this like framed like this, like which I think was how Mike Noether initially framed it. Do you think like this will help Ethereum moving forward, like as in like actually like leave enough room like for new features, or do you think that like because we are talking about like accelerate everywhere and so on, do you think it's a bit too late and maybe like there are other ways like through blobs or like sorry, I'm going in a lot of directions, but the question is simple, like how much processing do we get from Pectra basically?
So I think like I think your first point you mentioned was this EIP 7251, right? That you essentially allow you to reduce the validator size on mainnet. I think that's a very underrated EIP. A lot of people kind of just see the EIP as it is, but this EIP enables us to do many more things. For example, like single slot finality, like even Orbit SSF. There's also like 3SF. There are a bunch of proposals out there, right? But today, I think the consensus is the backbone. It's not very ideal because you have this like LMD Ghost 4 choice, you have your FFHG finality, and then everyone relies on this like finalized checkpoint, but it happens every 13 minutes. So and then and people don't really question is that why is it 13 minutes? Can we shorten that to 2 slots? What is the compromise when we do that, right? So we need some sort of like, I would say, faster finality, but without sacrificing too much like security. Maybe have some more like synchrony assumption. I think that's okay to make. But I think in order to do that, we must consolidate, reduce the amount of messages we have on the mainnet. So today it's ridiculous. You have essentially $1.1 million 1.1 million keys per 32 slots. You divide it by 32. That's a lot of messages just passing around the network, right? And then if we can consolidate those messages, like you can open a lot of like doors for all sort of design. And I think that is actually a very underrated EIP. And then I think like, I'm definitely looking forward to see what this EIP will enable in the future.
Thanks. Like I think it's going to be very interesting to follow the dynamics once Pectra goes live, like to see who consolidates and how the validator set evolves. And it's also a weird problem to have because I think like most other blockchains don't have like 1 million validators. Like it's a very unique engineering thing we are working on.
Right.
On Ethereum. So you mentioned also this a bit before about like the way the EIPs were selected and the fact that Pectra was basically a version of Ethereum without one big feature that was like this is what we want. And I think like you mentioned there was like a retrospective like some weeks ago on like what basically went right and wrong on Pectra. So well, like what's your take? Like what went right and wrong from your perspective, and what should be addressed for the next upgrade?
Yeah, I think what went right is definitely testing. We learned a lot on just how to do testing better, like what is fast testing. The fact that we're still finding consensus bug like last week, which is very, very like late in the stage to be finding those type of bugs, shows a lot about like testing, but not in a bad way, but in a good way that like testing can continue all the time. You don't have to wait until all the clients code ready to do testing. If Lighthouse is ready and Nimbus is ready, don't wait for Prism. Just go launch your DevNet, start doing testing, start fuzzing and finding bugs, right? I think previously we have this notion of like, we want to wait for everyone and then go together. But that eventually delays it, I think. So that's probably one learning, one feedback that we have. The second feedback, it wasn't our feedback, but I see a lot of it, is that kind of do some sort of like pipelining. I'm kind of playing the war here, like pipelining for hard fork, for example, kind of like how we do it for PIA-DOTS, where we finalize the scope for N and then for N+1, but we ship N, but the N+1 scope is essentially finalized already, so you cannot really change it. Then you start paying for N+2. So you kind of have some sort of like pipelining, so it allows smaller fork, but happen more frequent. So maybe instead of doing like 1 fork per year, which is like it's very slow. Maybe you can do 2 to 4 hard forks per year. And then there are some people that mentioning more like having some sort of a committee that's like steering, like help with the guidance, what EIP to include. Kind of like how Kubernetes does it, which I didn't read so much on that, but some people did mention that. But yeah, I think all the feedback is great. I think like going back to the first question, like what was my impression? I think my impression is that we learned a lot from Pectra, and then I think those experience is very great, and we'll definitely take those learning to Fusaka.
Yeah, definitely interesting, and kind of looking forward as well to see it live on mainnet and see all these new dynamics. I think we'll also learn a lot, like not only from the way it works, but from what people will do with it. So yeah, very interesting. And yet, so maybe like we talked a bit about the Beam chain, but if we look like, for example, in the next few years, let's say we do a new podcast in 2 years, what would you expect to happen until then? What are you bullish on until then? Especially like for the Prism roadmap.
Yeah, I think maybe I can talk about Ethereum in the beginning first. So on the Ethereum, I think we'll definitely see a lot more blobs one way or another, because like for Ethereum to be competitive, it has to compete on this blob space thing. And then that's the first thing. The second thing is execution, like how much essentially like gas limit you can put in a block, right? So if you look at Ethereum for the last few years, like they have been very slow since in terms of this like scaling thing. Besides like blob scaling, which was a very, very nice approach, that the gas limit hasn't increased for some time until Pectra, or sorry, not Pectra, this is not hardware dependent, but until a few weeks ago, we increased to 36, and that's about a 20% bump. I think we'll see more aggressive push by the community on just scaling, and then there's blob scaling and then execution scaling. And then I don't really have a number in mind, but I think we will probably see like literally 4x or even 10x. I think we'll do this without sacrificing security and decentralization, which is, I think, a hard problem, but I think we can get there. I think the second thing we'll see is I'm very excited, is a better pricing model. So today, I think the whole pricing of the opco thing is flawed in a way. It's just a single gas unit, but it's used across storage, compute, and then state growth and stuff like that. I think we'll see a better pricing model in the next few years that allows us to scale better, because there is a better because there is a better pricing model. I think another thing we'll see is probably maybe it's unrelated, but better interrupt in general between layer 1s and layer 2s. I think today the interrupt is not very nice on bridging and stuff like that, but there are a lot of proposals out there by different layer 2 teams, companies. They're doing more like intent-based interrupt, for example. This will allow better user experience. I guess one last thing, since I'm talking about user experience, that I think that EIP 7702 will also make a huge difference, which we will start seeing this year. Just like instead of sending like 3 transactions to approve, blah, 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 you need to send 1 transaction. And I'm very excited to see what people build there. Yeah.
Right. Very cool. Yeah. So yeah, we've been like, I think it's almost the end of this podcast. So we have like 2 more like open questions. Like so like the first one is easy. Like it's about like where can like our listeners get information about Prism, or like what's your recommended let's say channel or like resource?
Yeah, definitely just GitHub, Discord, Twitter. But don't just join the Prism Discord. It's kind of boring. You should join the Ethereum R&D Discord. That's more fun. You see all the client teams there. So yeah, I would say, Prism is great, but like there's so much you can do in Prism. Focus on Ethereum as a whole. So like the Ethereum R&D Discord, Ethereum Twitter account. I think they have been tweeting more now, so that's pretty awesome. And then just follow all the old core dev process. It's all in the PM issues, and all the breakout rooms are in the open. Yeah.
Nice. Yeah, like it's quite intense to follow if research, and like Discord are sometimes intimidating, I would say. And do you have a like particular book or reading to recommend to our audience, or
Yeah.
that influenced you?
So I'm kind of convinced to myself that I will be out of a job if I don't learn ZK in a few years. So I've been reading more cryptography related book. I think there's one called like Moon Math for cryptography. It's really good. And then there are the latest white paper by Justin Drake and the Ethereum research on hash-based hash-based signature aggregation type of thing. I think that's also very interesting. So mostly cryptography, but for cryptography, you just start at the beginner level. There are actually really good books out there. That's very easy, simple math to understand. And that's where, that's what I'm focused on these days.
So getting ready for BEAM.
Getting ready for a ZK paradigm, yeah.
Well, thanks a lot for this podcast, Terence. So thanks Eric as well for your time. And I guess thanks a lot for our listeners who went through the end of this podcast. And let's see you on the Ethereum Research and Development Discord.
Thank you guys.
See you.
See.